Good morning, afternoon, or evening. Welcome back to Mr. Morrow's Algebra class. Today we are going to continue with Chapter 4. We've been dealing with linear equations, okay? Just as a little preview, so far we have learned about slope, okay, which is the rise over run. We've learned what a function is. We've learned about relations. We learned about direct variation, y equals kx. We learned standard form. Standard form is ax plus by equals c. That's standard form. And today, we're going to use, I think, one of the most powerful tools, and that's the slope-intercept form. Today, we're going to talk about the slope-intercept form. We have discussed the slope-intercept form. It's the y equals mx plus b equation. But today we're going to learn how to use that to graph without making a table. After today's lesson, you will never have to make a table for a linear equation. Now, what's a linear equation? Let's talk. A linear equation or function is an equation where x has an exponent or power of 1. So for example, y equals 2x plus 5. Please remember that there's an invisible 1 here. So in any linear equation, today we're going to learn how to graph it without having to make a table ever again. So a linear equation has an x with a power of 1. A linear equation or function produces a straight line. So please, guys, if you're graphing and it has a jagged edge, it's going up or down, like a heart rate, it has a curve, it's angled. I'm sorry, but you messed up. You made an error. No big deal. We're all human. But you got to be able to recognize that error. Now, there's two methods for graphing. The first method we've already learned. It's called the table method, and you know that already. So I'm going to go pretty quickly over this. You simply create an x and y table and choose values for x, the independent variable. Then you evaluate the function for the values of x that you have chosen. I like to use the Morrow 5, -2, -1, 0, 1, and 2. However, if the number in front of the x is a fraction, remember that you don't use the Morrow 5. You use multiples of the denominator. And of course, 0. You always use 0. Okay? Then you graph the ordered pairs and you draw the line. So we're going to go by pretty quickly on this one because we've already been tested on this and you know how to do this, hopefully. When x is -2, y is 10. Very good. When x is -1, y is 7x. And when x is 0, y is 4. When x is 1, y is 1. When x is 2, y is -2. So I've got -2, 10, -1, 7, 0, 4, 1, 1, and 2, -2. Straight line, bam. That's how I graph using the table method. That's pretty straightforward. You can use that if you want. It's not super efficient, and it's time consuming. And if you're not strong with addition and subtraction and multiplication, you could make a lot of errors. So because of that, we have a second method which we're learning today. And the second method is the slope-intercept method. In order to work with the slope-intercept method, you must really memorize the slope-intercept form. The slope-intercept form is y equals mx plus b. Y is always the dependent variable. It depends on x. M is the slope. Remember, slope equals the rise or fall over run, And the formula is y2 minus y1 over x2 minus x1. The x is always the independent variable. Good job. Let me move this out of the way. Independent variable. And the b is the y-intercept. That's the y value on the y-axis when x equals 0. If you know that, you can graph. How does it work? Step 1, solve the equation for y. In other words, you want to get y alone, and you want to solve for y so you can have the slope-intercept form y equals mx plus b. You want to solve for y. You want to solve for y. The slope-intercept form, y equals mx plus b. Step 2, identify and graph the y-intercept. Identify and graph the y-intercept. That is the b value. So when x is 0 here, 0 times m, that cancels out, so y has to equal the b value. So when you look at your slope-intercept form, if you know what you're looking at, the b is your y-intercept. So you're going to identify that and graph it. And step 3, from the y-intercept, follow the slope for 3 to 5 points going both forward and backward. Okay, from the y-intercept, follow the slope for 3 to 5 points going both forward and backwards. So you solve for y, put into y equals mx plus b form. Number 2, identify and graph the y-intercept. Number 3, from the y-intercept, follow the slope 3 to 5 points going both forwards and backwards. Now, let's put this into practice. Graph each linear function using the slope-intercept form. But I have a little star here because I want you to remember something. Remember that when using the slope to find new ordered pairs, you must run to the right unless you're going backwards. And I'm going to explain that in a second. You want to run to the right unless going backwards. Excuse me for 1 second. Okay, so let's get to it. First things first, we got to solve for y. Number 1 is already solved for y. It's y equals 3x. So what I like to do is I like to help myself. I like to label things. What's my slope? 3. What's the denominator of 3? Okay, so you're going to rise 3, run 1 to the right, unless going backwards. What's my y-intercept or my b? 1. Step 2 says identify the y-intercept and graph it. So my y-intercept is 0, 1, so that's right here. Is everyone with me? Now, pay attention. Follow the slope for 3 to 5 points forwards and backwards. Stop writing, eyes on the board. Stop writing, eyes on the board, please. Here's my y-intercept. So I'm going to go up 1, 2, 3, 1 to the right. Up 1, 2, 3, 1 to the right. Now let's go backwards. So when we go backwards, we do the opposite of this. Instead of going up 3, we go down 3. Instead of going 1 to the right, we go 1 to the left. So you go back to your y-intercept, down 1, 2, 3, 1 to the left. Down 1, 2, 3, 1 to the left. Connect the dots. And now I can check. I can prove that it is a straight line with the right slope. Up 3 over 1. Up 3 over 1. Up 3 over 1. Up 3 over 1. Remember that slope is constant. And guess what, guys? You never have to make a table again. All right? Okay, number 2. What's the first thing I got to do here, gentlemen? Solve for y. Not standard form. No. It's already in standard form. You want to put it into slope-intercept form. So that means you have to solve for y. You want to find y equals mx plus b. So how do I start solving for y here? You subtract 5x to both sides. So I got negative y equals negative 5x minus 3. What does this negative in front of the y represent? So let's divide by negative 1 to both sides. So y equals, the negative 1 gets divided to everything. So it's going to be 5x plus 3. What's my y-intercept, boys? 3. 1, 2, 3, 0, 3. Good. What's my slope? 5 over, so up 1, 2, 3, 4, 5 over 1. I can't go any further forward, so let's go backwards. Down 1, 2, 3, 4, 5 over 1. Down 1, 2, 3, 4, 5 over 1. Straight line. You don't have to do this at home, but just so you know, so I'm teaching, make sure you understand the slope is the same. Up 5 over 1, up 5 over 1, up 5 over 1. Does that make sense, gentlemen, what I just did? Promise. Okay. Yes, sir. I didn't go up 3. No. I started at the y-intercept of 3. That's where I started. Then I followed my slope. Up 1, 2, 3, 4, 5 over 1. Then I go back to my y-intercept and I go backwards. Down 1, 2, 3, 4, 5 over 1. Down 1, 2, 3, 4, 5 over 1. And I connected those ordered pairs. Thank you for your honesty, sir. Did that answer your question?
Yeah.
Thank you, sir. May I continue? Okay. Graph each linear function using the slope-intercept form. Okay. So I got y equals negative 0.2x plus 3. But what's the problem here? What's the problem with this slope here? It's in decimal. I need it in a fraction. So what is 0.2 in fraction form? What's negative 2 over 10 reduced? So it's negative 1/5 x plus 3. Okay, now, what's my y-intercept, boys? 3. So I go 1, 2, 3. Does everyone see that I start at the y-intercept? Okay, pencils down for 1 second, eyes up here. It's negative, so does that mean fall or rise? Okay, but remember, you always run to the right, even if it's a negative slope. So I'm going to go down 1 over 1, 2, 3, 4, 5 to the right. Down 1 over 1, 2, 3, 4, 5 to the right. Now I'm going to go backwards. So backwards would be I'm going to go up 1 over 1, 2, 3, 4, 5 to the left. Up 1 over 1, 2, 3, 4, 5 to the left. Does that make sense? And now look, guys, isn't it a negative slope? Isn't this going down from left to right? So that's a good way to test it. Okay, number 2. What's the y? Come on, man. Why is this not working? Come on. Okay, there we go. Number 2. What we've already solved for y. It's already in y equals mx plus b form. What's my y-intercept? Negative 2. So start at negative 2. What's going on here? Okay, negative 2. What's my slope, gentlemen? 3/5. So I'm going to go up or rise 1, 2, 3. Run 1, 2, 3, 4, 5. Always to the right unless going backwards. Up 1, 2, 3 over 1, 2, 3, 4, 5 to the right. Now I'm going to go backwards. So I go back to my y-intercept. Down 1, 2, 3 over 1, 2, 3, 4, 5 to the right. Connect the dots. Bing, bang, boom. I'm done. Yes, sir.
How do you know whether to go 4 points or 5?
I went 4 points here because I didn't have much more space. I could have gone a 5th one though in this case. 1, 2, 3 over 1, 2, 3, 4, 5. In this case, I could have had space. So yes, with space, being an issue, that's why it's between 3 and 5. So if you can fit 3, I'm good, if that's all you can fit. If you can fit 4, great. If you can fit 5, great. You don't need more than that, sir. Thank you very much, son. Okay. Ooh, wait a second. What the heck is this, Mr. Moore? What are you doing to us? Y equals 4. We've gone over this already. What's the slope of a line like that? What's the slope of a line like that? 0. What kind of a line is that? A horizontal or a vertical? Y equals, guys, horizontal. So I go 1, 2, 3, 4. Remember, we've already talked about these, guys. What about x equals? What kind of a slope is an x equals? Undefined. Is that a vertical or a horizontal line? Vertical. So I go to negative 1, 2, 3, 4, 5. That's where my x is going forever. Because in any point here on this line, what's the value of x? Exactly. On any point on this line, what's the value of y? Exactly. Okay. Next, what's the y-intercept? 5. So I go 1, 2, 3, 4, 5. What's my slope? So I go down 1, 2 over 1, 2, 3. Down 2 over 1, 2, 3. Go backwards. Up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Bam. Done. Next. How do I solve for y here? Subtract 5x to both sides. So I've got 3y equals negative 5x minus 12. Now what? Divide both sides by 3. So y equals negative 5/3 x minus 4. What's my y-intercept? What's my y-intercept? 1, 2, 3, negative 4. What's my slope? Negative 5/3. So I go down 1, 2, 3, 4, 5 over 1, 2, 3. Now go backwards. Up 1, 2, 3, 4, 5 over 1, 2, 3. Connect the dots. And I'm golden. Does that make sense? Yes? Why is it 4, you ask? Because 3 gets divided to the negative 5 and to the negative 12. Now, last thing before the bell rings. I can tell you to reverse all of this. I can give you a line and say, what's the equation of the graph? Well, think about it. I need a slope and a y-intercept, right? What's my y-intercept here? 3. So my b is 3. Now, how do I find my slope? I have one perfect point here. I go to the next perfect point. Remember, it's the crosshairs, like a video game. And I go up 1, 2, 3 over 1, 2, 3, 4. So my slope is 3/4. So what is my equation? Y equals mx plus t. Here, for number 2, this vertical line. What kind of an equation is that? An x equals or a y equals? That's an x equals. What is it going through? 1, 2, 3, 4, 5, negative 6. What kind of a graph is a horizontal? A y equals or an x equals? There's a y equals 1, 2, 3, 4, 5. Negative 5. Last but not least, what's the y-intercept here on the green? It's right here. Negative 9. So my b is negative 9. Now, perfect point would be here. So from left to right, this is down 1, 2, 3, 4, 5, 6 over 1, 2. So my slope is down 6 over 2, which is negative 3. So y equals mx plus b. And you were done. Thank you very much. Have a great day. Hope you learned a lot. Do your homework. Study hard. Bye-bye.